Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Walker Graham Middle School. And in this video, we're going to be closing out that SOL review guide, working with that SOL 8.18, talking about everything inequalities. So, some things to remember. Again, make sure you have that golden rule of inequalities. Anytime you multiply or divide by a negative number, you have to be able to change that direction of the inequality symbol. Again, that's only when you multiply or divide both sides by a negative number. And if you get a result that is negative or you get a result that's positive, it's only when you multiply or divide by a negative number. Also, do make sure you can use that Desmos Calculator. It will be similar to how you do expressions and equations. However, keep in mind, again, it's an inequality. So it could be less than, greater than, or equal to any of those situations, so make sure that you are paying attention to that. Also too, if you are graphing on that number line, make sure you're seeing those ideas. Again, if it's greater than or less than, it's an open circle, but if it has that filled in line, it's going to be a filled in circle, so make sure that you're using those carefully. So for number one, it says solve and graph the solution set of this inequality. So what I'm going to do is this. So let me scroll that up. All right, so for number one, I have this. I have 4 greater than or equal to negative 2 times quantity x plus 2. Again, make sure that you can use that distributive property for yourself. So I'm going to have negative 2 on the outside times the terms inside the parentheses of positive 1x, and I have a positive 2. I have negative 2 times positive 1x is a negative 2x, and negative 2 times a positive 2 is negative 4. I'll just write that underneath. So I have 4 is greater than or equal to, and then I have negative 2x minus 4. Be able to get that variable by itself, so I'm adding 4 to both sides. So let me bring this down. So I have, that cancels out. If I multiply or divide by a negative, the sign changes, otherwise it's going to stay the same. So I have greater than or equal to, and then 8 and negative 2x. Divide both sides by that coefficient. Since I multiply or divide by a negative, that's when I change that direction, and so I have negative 4 and then x. Again, make sure you can write that variable on the left side. So I'm going to say x is going to be greater than or equal to negative 4. So that means this, I'm going to have a closed circle on negative 4. So let me have a closed circle on negative 4. And I'm saying, okay, everything to the right of it. And it's saying any value that is greater than negative 4 is an answer. All right. Again, you can also check using that Desmos Calculator to see if it works. So what I can do is this. Let me say, I can type it in exactly as it looks, so I can actually say negative and then 2 times quantity x plus 2. If I am looking carefully, I'm saying, okay, I could include any of these values. So I usually like to use 0. So let's say when x equals 0, is that value is 4, I'm saying this is 4 greater than or equal to negative 4. It is, since it's greater than. So since it is true, it is included. All right. For number 2, it says solve for x, and so I have this inequality. So I can have 5x plus 1 minus x is greater than 10 plus 3x. Be able to combine those like terms, so I'm going to say I have 5x and negative 1x is going to be 4x plus 1. The rest stays the same. Since I have variables on both sides, I want to get rid of the lower one, so I'm going to subtract 3x from both sides. And so I have x plus 1 is greater than 10. And I subtract 1 from both sides, I have x is greater than 10. Excuse me, yeah, greater than 10. How about greater than 9? Greater than 9, there we go. So now I can say x is going to be greater than 9, and if I wanted to graph it out, I'd have an open circle on 9, and I'd be shading to the right. All right, moving on. It says this, let me actually shift this over. It has select all the solutions to the inequality that are true. So I have this as my inequality. So I have, let me do it like this, write it down. So that way we have, so this is again number 3. So this is 3 minus x. I have 3 minus x. If I can actually think and write at the same time, that would be a miracle. Is less than, and then I have negative 2x plus 1. Okay, what I can do is this. I could actually just plug in and see which ones work out. So let me actually do that first. Let me actually do that. Let's keep it simple for this one. So I'm still on number 3. What I'm going to do is this. I'm going to type it in exactly as it looks. Type in that left side of my equation. Equation, inequality. I have 3 minus x. I have my right side of my equation, negative 2x plus 1. What I'm saying is this. It has to be less than. So it has to be less than. So this first number on top has to be less than this bottom number. So let's try it out. So let's say when x equals negative 5, is 8 less than 11? It sure is, and so we're good. How about when x equals 0? That is not true since 3 is not less than 1. 0 is not in a solution set. How about negative 7? That is true. How about 1? That is false. How about negative 2? Since those two are equal, we're not going to include it because it's saying strictly less than. So we only would include that if it had a filled in line. How about when x equals 3? Is 0 less than negative 5? It is not. And so we're not going to include that. How about positive 5? Negative 2 is not less than negative 9. Again, make sure you know where you're at on that number line. And how about that last one? That is true. All right. Moving on, I'm going to actually do the same kind of setup for number 4. I'm going to type it in exactly as it looks because it gives me some choices. So I'm going to say, all right, 6 minus 5x. And I'm saying all that divided by 4. That has to be greater than. So now looking for that first line to be greater than the second line. So I have negative 8x and plus 1. What about when x equals a negative 1? So we're looking, is that first value greater than the second value? It is, and so we are actually good on that one, and we can move on. For number 5, let me actually read it out since I have that part there. So it says, I don't know why it's split here, but it's okay. It says the band is raising money for their spring trip. They need to raise at least $1,500. Earlier in the year, they made $575. $575 on their annual fruit sale. Now they're selling donuts, and they will earn $5 profit for each box of donuts they sell. Which inequality could be used in order to determine the number of boxes of donuts D that they must sell for their goal? So again, we could say this. So we're saying, okay, they want to have at least $1,500. So make sure you're using that keyword at least 1,500. Since it has at least, we're saying we can have values greater than 1,500, and so that's why I can cancel out these two choices. And then also too, we're not taking away money when we're selling those donuts, and so that's why we would not include choice B. And then for number 6, it says the graph represents solutions to which inequality. What I can do for this one is this. I can solve each of these and have a long time doing it, or I can choose a value that is in this solution set. So let me actually do this. I'm going to check to make sure that 7, 8, and 9 work for one of these inequalities. So I type it in exactly as it looks. So for choice A, I have 3x minus 4 is less than x, or 6x plus 8. So let's see, when x equals 7, that is less than the second value, so that works. How about when we have 8? That also works. How about when we have 9? That also works. How about when we have 10? That also works. So actually it is just that first one. So let me double check. All right, so the reason why I'm actually not going to select this one is because of this. Even though 7 and 8 work, when I try out 6, it does actually work, which this is not a filled in line. And so if I need to still show, so when I plug in 5, should not work, as it is not in the solution set. When I plug in 5, it does work for that first one, so it cannot be that one. All right, moving on. How about that next one? It says 5x is greater than or equal to, well, right away, boom, I have a filled in line when I don't have a filled in circle, so it can't be that one. How about the next one? It can't be D either for that same reason, but I can prove for this one why it would work. So I have x plus 4, and then I have all over 2. I'm saying that's less than x minus 1, and let's try it out. So it should not work for x equals 5. We said this is not less than that, so we're good so far. Since that does not work, we're good. How about when x equals 7? Left is less than right, and so we are good. So we would pick C for that one. That was a little bit trickier, but we're okay. Moving on, it says the coach has $400 to spend on the end of season party. She purchases awards for $80 and decorations for $35. She will use the remaining money to order pizza. If the pizza costs $20 to $12 each, what is the most amount of pizza that they can buy? So for, again, number 7, you can't spend money you don't have. So again, let me do it like this. I could say for number 7, let me actually scroll that down and make sure it's on screen. Sure. All right, so for number 7, again, I can have something like this. I can say it's $12 for each pizza, and if I total up 80 and 35, that's $115. And I'm saying I can spend at most $400. So I can set it up as that for my inequality. Subtract 115 from both sides, and so I have 12p is less than or equal to, and then I have 285. Divide both sides by 12, and we have that this is going to be less than or equal to $23.75. Actually, I don't think it's in dollars. It's saying pizza. What is the most amount of pizza I could buy? Well, since I can't buy a full 24 pizzas, I would have to stay with 23. So again, make sure that you see that key part. Since our value is at most 23.75, we couldn't go up to 24, and so we could at most buy that $23 and maybe leave a little bit for the tip for delivery. All right, moving on to number 8. Let me make sure, perfect. For number 8, it says match each inequality for that solution set. All right, so let me actually crunch some of these out for us. So for that first one, what I'm going to do is I'm going to do each of these one at a time, and then get those solution sets. So I'm going to say, all right, I have x minus 3 plus 2x is less than x plus 5 plus x. Combine like terms on the same side first. So I can say this is going to be 3x minus 3 is less than 2x plus 5. Subtract 2x from both sides. I have x minus 3 is less than 5. Add 3 to both sides. I have x is less than 8. Let me double check for that as well. Yep, good. And I can say, all right, I have an open circle on 8, and I'm shaded to the left. Then I have, so that would be, let's double check. Open circle on 8 and shaded to the left is going to be B. And for this one, I have 2x minus 3x plus 2 is going to be greater than x plus 6. And so I can say I have, combine like terms on the same side. So I have, this is going to be negative 1x plus 2 is greater than x plus 6. Again, since this one is lower, I'm going to add the opposite to both sides. So I'm going to add 1x to both sides. I have this cancels out. 2 is greater than 2x plus 6. Subtract 6 from both sides. I have negative 4 is greater than 2x. Divide by 2 to both sides. And I have negative 2 is greater than x, which is the same as x is less than negative 2. Open circle on negative 2, and I'm going to be shading to the left again. So open circle on negative 2, so it's going to be C for this one. So I have B, I have C, and for this next one, I have x plus 1 plus 4 is greater than or equal to, so I have a closed-in circle, and I have x plus 5, actually, that's not the same, okay. I thought it was the same, so I could save some time, but that's not, that's okay. I have this, I have x plus 5 is greater than or equal to 2x plus 5, again. Let me double check. Yes, I have subtract x from both sides. I have 5 is greater than or equal to x minus plus 5. And then I can subtract 5 from both sides. Even though I have 0 as an answer, that's okay. That is possible, and so I'm going to have x is less than or equal to 0 for that one. So that means I have a filled in circle on 0, and I'm still shading to the left. And so filled in circle on 0 is going to be A for that one. And lastly, I'm going to have D for that. I can move on. For number 9, it says select 3 numbers. So 3 are true, 3 are false. That would work for that inequality. So I'm going to say that, okay, I have to have that my top, or my first section is going to be less than. All right. So on the left side, I can say 3 over 4 times x minus x plus 2 is less than, strictly less than, 1 over 2 times x plus 8. So I'm going to plug in some values to see if they work. So again, the top value has to be less than that second value. So I'm going to say x, what about negative 11? That is false. What about 0? Solutions that are true. So let me make sure I typed it in correctly for this. 3x and then half less than. Oh, so that's why. Okay. actually not those three. Let's flip it around. So it should be x is less than, sorry, greater than, greater than 8, which is not those. Okay, so let's double check. So I have 0. First one is less than the second one, so it is included. How about -9? False. How about 1? I would include, again, first value is less than the second value. How about -8? Again, same value, those would be equal, but we are saying strictly less than, so we can't include that one. How about 3? We would include, all right. Again, make sure you can ask a question at any point in time. Otherwise, be sure to super slam that subscribe button.